you've been doing everything right. 16 hours of discipline, 16 hours of saying no to the snacks, the late-night meals, the morning toast. You woke up feeling lean, focused, maybe even a little proud. And then you walked into the kitchen and made one decision, one single bite that quietly undid a significant portion of everything your body just spent the better part of a day building. Not because you cheated, not because you ate junk, but because nobody ever told you that after a 16-hour fast, your biology doesn't care how healthy the food is. It only cares what that food is made of and what it signals your body to do the moment it arrives. The first thing you eat after a 16-hour fast will either flood your muscle tissue with the building blocks it's been waiting for, or it will flip a switch that drives everything straight into fat storage. All of it. And the cruel part is that the foods most people reach for, the ones they genuinely believe are healthy morning choices, are the exact foods that trigger the worst possible response in a fasted body. This isn't about willpower, it's not about discipline, it's pure biology. And once you understand what's actually happening inside your body at the moment you break a fast, you will never look at your morning meal the same way again. Let's start at hour 0 of your fast, because what happens during those 16 hours is the entire reason the first bite matters so much. In the first few hours after your last meal, your body is still running on glucose from digestion. Insulin is elevated, fat storage is active, and your metabolism is in a fed state. Nothing unusual. But somewhere between hours 10 and 12, your liver runs out of glycogen, the stored sugar it keeps on hand as a quick energy reserve. When that happens, everything changes. Your pancreas drops insulin to its lowest levels of the entire day. We're talking 60 to 70% lower than what you'd see after a typical meal. And when insulin drops that low, something remarkable happens inside your fat cells. An enzyme called hormone-sensitive lipase gets activated. This is the enzyme that physically unlocks stored body fat and releases it into your bloodstream as free fatty acids. Your body, for the first time in hours, is genuinely burning fat as its primary fuel source, not as a minor contributor, as the main event. Around hour 14, autophagy ramps up. This is your body's cellular housekeeping process, where your cells break down and recycle their own damaged components, old mitochondria, misfolded proteins, cellular debris that contributes to aging and inflammation. Your cells are literally cleaning themselves from the inside out during this window. At the same time, human growth hormone surges. Research published in the Journal of Clinical Endocrinology and Metabolism found that a 16-hour fast can increase growth hormone secretion by up to 300%. That hormone does two critical things. It preserves your muscle mass while your body mobilizes fat for fuel, and it drives the repair and rebuilding of muscle fibers that broke down during the fasting period. So by hour 16, your body is in an extraordinary state. Fat burning is maximized, cellular repair is actively happening, inflammation is down, insulin is at its floor, and every cell in your body, your muscle cells especially, has become profoundly sensitive to whatever signal arrives next. This is called insulin sensitivity, and right now, at the end of a 16-hour fast, your body is more insulin sensitive than it will be at any other point in the next 24 hours. That sounds like a good thing, and it can be, but it is also exactly what makes the first bite so dangerous if you get it wrong. Here is what happens the moment glucose hits your bloodstream after a 16-hour fast. Your pancreas sees glucose in the blood and releases insulin in proportion to how sensitive your receptors currently are. But your receptors are at peak sensitivity right now, so even a small amount of glucose, the kind you'd get from a banana, a piece of toast, a glass of orange juice, triggers a disproportionately massive insulin response. A 2018 study in Cell Metabolism measured insulin responses in subjects after a 16-hour fast versus subjects after a normal overnight sleep of 8 hours. The fasted group produced insulin responses that were nearly double the magnitude for the same amount of carbohydrates consumed. Double from the same food, simply because of the metabolic state they were in when they ate it. And here is the part that changes everything. When insulin spikes that high, it doesn't just help glucose get into your muscle cells, it activates fat storage. High insulin is the biological lock that keeps fat trapped inside your fat cells. When insulin is elevated, your fat-burning enzymes shut down completely. That free fatty acid flow that's been running for the past 6 hours stops cold. And all that glucose, instead of going toward muscle repair, instead of fueling your brain, gets driven into fat cells at an accelerated rate. You spent 16 hours building a perfect fat-burning, muscle-repairing metabolic state, and in under 5 minutes of eating the wrong thing, you've essentially flipped the switch back to fat storage mode. The food didn't cause this on its own. The food caused this because of when it arrived. The same oatmeal that's a perfectly reasonable lunch is metabolically counterproductive at the end of a 16-hour fast. Timing is everything. And this is exactly what the first bite rule was built to solve. The first bite rule is simple. Your first meal after a fast must be protein and fat dominant, with essentially zero fast-digesting carbohydrates. Here's why this works at the physiological level. Protein does not spike insulin the way carbohydrates do. When you eat protein after a fast, your body releases a modest insulin response, enough to start shuttling amino acids into muscle cells where they've been needed for hours, but not enough to trigger that cascade of fat storage. Dietary fat from sources like eggs, avocado, olive oil, and nuts releases almost no insulin at all. So when your first bite is protein and fat, something elegant happens. Your muscle cells get the building materials they've been waiting for, your fat-burning machinery keeps running in the background because insulin stayed low enough to allow it to run, and that extraordinary receptor sensitivity you built over 16 hours gets channeled into muscle repair instead of fat accumulation.
There's a second mechanism here that most people miss entirely. Protein triggers glucagon, the hormone that is the direct counterpart to insulin. Where insulin drives glucose into storage, glucagon pulls it back out. In a fasted state with a high-protein first meal, glucagon stays relatively elevated, which means your liver continues releasing small, controlled amounts of glucose into the blood at a steady rate. This is what gives you that clean, stable energy after a protein-based breakfast meal. You have probably noticed the difference without knowing why. The mornings when you break your fast with eggs versus the mornings you break it with cereal. One leaves you energized and sharp for 3 to 4 hours. The other has you crashing and reaching for coffee again inside of 90 minutes. That difference is not in your head. It is your hormones responding to two very different first bite signals. Now let's talk about ghrelin, the hunger hormone, because this is where the first bite rule pays dividends that go well beyond the first meal. Ghrelin peaks right before you eat and drops sharply after eating, but it drops far more sharply after protein than after carbohydrates. A study from the American Journal of Clinical Nutrition compared ghrelin suppression after high-protein meals versus high-carbohydrate meals following a fast. High-protein meals suppressed ghrelin for an average of 4 hours longer. 4 hours where you were not hungry. 4 hours where you were not reaching for snacks or fighting cravings. When you break a fast with sugar or refined carbohydrates, ghrelin rebounds fast, sometimes within 60 to 90 minutes, leaving you hungry again before you have even properly digested your first meal. This is why people who eat relatively clean but break their fasts with fruit bowls or green smoothies report constant hunger throughout the day. The hunger is not weakness, it is a direct hormonal consequence of the wrong first bite. Before we build the ideal breakfast meal, you need to know which foods are causing the most damage, because several of them are disguised as healthy choices. Fruit juice is arguably the worst offender. A medium glass of orange juice contains roughly 21 grams of sugar, almost all of it fructose and sucrose. Fructose doesn't follow the normal glucose absorption pathway. At high concentrations, it goes directly to your liver, where it can only be metabolized one way: conversion into fat. This is called de novo lipogenesis, your liver literally manufacturing new fat from fruit sugar. After a 16-hour fast, your liver is biochemically primed for this response. A glass of juice is one of the worst possible ways to break a fast, regardless of how natural or organic the label claims it is. Oats and granola are the next myth worth dismantling. The health food community has spent decades promoting oats as a clean, wholesome breakfast. In certain contexts, that's partially deserved, but at the end of a fast, oats spike blood glucose fast enough to trigger that disproportionate insulin response we've been talking about. The glycemic index of rolled oats sits around 57, not catastrophic in isolation, but combined with the hypersensitivity of a fasted metabolic state, the effective glycemic response is amplified well beyond what those numbers suggest. Protein bars and meal replacement shakes are particularly deceptive because people assume that if something contains protein, it is safe to break a fast with. Read the label on the average protein bar. You will find 20 to 30 grams of protein alongside 20 to 35 grams of sugar or maltodextrin, a carbohydrate with a glycemic index higher than table sugar. The protein in that bar will not protect you from the insulin spike triggered by the carbohydrates. You are essentially getting a sugar bomb in a protein wrapper. In sweetened yogurt with fruit, sports drinks containing dextrose, flavored electrolyte beverages, all of these fall into the same category. They arrive in a fasted body and immediately trigger the exact hormonal cascade you spent 16 hours preparing to avoid. So let's build the meal that actually works. Your ideal break-fast meal has 3 components in specific proportions. First, a high-quality, complete protein source, providing 30 to 40 grams of protein. Research from the International Society of Sports Nutrition indicates that 30 to 40 grams of protein per meal maximizes muscle protein synthesis, the process of building and repairing muscle tissue. Going above 40 grams doesn't significantly enhance the response. Going below 25 grams leaves a meaningful amount of anabolic signaling unused. The critical factor here is leucine, the specific amino acid that acts as the trigger for muscle protein synthesis. You need a minimum of around 2.5 grams of leucine per meal to fully activate that pathway. The best sources are whole eggs, wild-caught fatty fish like salmon or sardines, grass-fed beef, full-fat Greek yogurt unsweetened, cottage cheese, and tempeh for plant-based options. Second, a moderate amount of dietary fat, 15 to 25 grams. Fat serves a crucial function here that goes beyond its caloric content. Fat slows gastric emptying. When fat is present in your stomach, your gut releases a hormone called cholecystokinin, which signals the brain that you're full and slows the rate at which food moves into the small intestine. This controlled release means that even trace carbohydrates in the meal get absorbed slowly and steadily, rather than flooding the bloodstream at once. Good options here are half an avocado, a tablespoon of olive oil, a small handful of walnuts or macadamia nuts, or simply the natural fat that comes from whole eggs and fatty fish. Third, optional non-starchy vegetables for fiber, micronutrients, and volume. Spinach, arugula, cucumber, zucchini, broccoli, asparagus. These add real nutritional density without meaningfully affecting insulin. What you are not including in this first meal is bread, rice, fruit, starchy vegetables, or anything with added sugar. You can reintroduce those in your second meal of the day. By that point, your metabolic baseline has fully reestablished and your insulin sensitivity has normalized. The same carbohydrates that are dangerous as a first bite become completely manageable a few hours later. Context determines biology, not just content. Here is a specific meal that hits every single target in under 10 minutes and costs under $6. 3 whole eggs, 2 ounces of smoked salmon or a small tin of wild-caught sardines, half an avocado, 1 cup of baby spinach, a quarter cucumber sliced thin, a tablespoon of extra virgin olive oil, sea salt, black pepper, and an optional squeeze of lemon. Heat the olive oil in a pan over medium-low heat and cook the eggs slowly. Low heat matters more than most people realize. It preserves the fat-soluble vitamins locked in the yolk, particularly vitamin D, which is one of the most critical regulators of insulin sensitivity. People with vitamin D deficiency are measurably more insulin resistant. While the eggs cook, build your base of spinach and cucumber. Add the avocado sliced rather than mashed, Intact cell structure slows oxidation and preserves more of the polyphenols. Lay the salmon on top, or drain and add the sardines. When the eggs are just set and still slightly glossy, pull them off the heat. The residual warmth will finish them in 30 seconds. Season, plate, and if you are using sardines packed in olive oil, use that oil as your drizzle. It is already infused with omega-3 fatty acids and adds depth that regular olive oil alone cannot match. The final meal delivers approximately 38 grams of protein, 28 grams of healthy fat, 8 grams of fiber, and fewer than 10 grams of net carbohydrates. Insulin response minimal. Leucine content above the muscle protein synthesis threshold. Ghrelin suppression lasting 4 or more hours. Nutrient density genuinely exceptional. Vitamin D, B12, choline, omega-3 fatty acids, potassium, folate, and a full spectrum of fat-soluble vitamins that can only be absorbed in the presence of dietary fat.
Now, here is the piece almost nobody accounts for, and it has nothing to do with what you eat. It is how fast you eat it. When you eat quickly, which most people do when they are genuinely hungry after a 16-hour fast, you overwhelm your digestive system's satiety signaling. The gut hormones that communicate fullness to your brain, including peptide YY and GLP-1, take approximately 15 to 20 minutes to register in your hypothalamus. If you finish your meal in 5 minutes, your brain has no idea you have eaten anything. In a fasted state, this timing problem is amplified by the intensity of hunger and the extraordinary vividness of food flavor that fasting produces. The practical solution is to eat your breakfast meal over at least 15 minutes. Put the fork down between bites. Chew each mouthful thoroughly. This is not an old-fashioned idea with no grounding. Thorough chewing activates salivary amylase, begins the digestion of trace carbohydrates in the mouth, and gives your gut hormones the time they need to properly assess what's coming in. It is one of the simplest upgrades you can make to your fasting protocol, and almost nobody does it. There are also 3 consistent mistakes that derail people even when they understand the first bite rule. The first is treating breakfast as a chance to compensate. After 16 hours without food, there is a powerful pull to eat more than usual. Your brain frames the fasting window as a deficit that needs correcting. But overloading your first meal, even with the right foods, overwhelms your digestive capacity and forces your liver, pancreas, and gut to divert resources from metabolic repair to managing sheer volume. The ideal breakfast meal sits around 400 to 600 calories for most adults, enough to fully break the fast and deliver the nutrients your body needs without overloading any system. The second mistake is adding carbohydrates within the first 15 minutes of the meal. Some people start correctly with protein, then add fruit or toast 10 minutes in, thinking the protein creates a buffer. Physiologically, it doesn't work that way. Your insulin response builds on whatever you have already eaten. Adding glucose to a system that just received a significant protein signal in a fasted state still produces a meaningful spike. Keep the entire first meal carbohydrate minimal. The second meal is where carbohydrates belong. The third mistake is breaking the fast too soon after waking. Many people on a 16-8 fasting protocol break their fast within 30 minutes of waking up. But cortisol, your alertness hormone, peaks naturally in the first 30 to 60 minutes after waking in a process called the cortisol awakening response. Cortisol elevates blood glucose slightly as part of your body's natural wake-up mechanism. Breaking your fast during that cortisol peak means your glucose is already slightly elevated when food arrives, which amplifies the insulin response to your first meal. Waiting 60 to 90 minutes after waking, even if your fasting window has technically ended, produces a noticeably more controlled metabolic response. You are eating into a calmer hormonal environment, and your body responds accordingly. What all of this points to is something larger than a fasting tip. Every meal you eat is a conversation between what you put in your mouth and what your body does with it. Insulin says store, glucagon says release, growth hormone says build, cortisol says mobilize. The translation of those signals, the actual physiological response your body produces, depends entirely on context. The same piece of salmon means something completely different to a body that has been fasting for 16 hours versus a body that ate a sandwich 2 hours ago. The same bowl of rice at dinner is metabolized differently than that same bowl of rice as the first meal of the day after a fast. Context determines biology, not just content. The first bite rule is the most accessible application of that principle because fasting creates the sharpest possible context. After 16 hours, your body has maximally sensitized its systems in a way that it does not achieve at any other point in the day. You have a brief window, the first meal after the fast, to either amplify that state or cancel it out. Most people, through no fault of their own, cancel it out every single morning with their juice, their oatmeal, their supposedly healthy granola bar. They do everything right for 16 hours, and then in the first 60 seconds of eating, they quietly undo much of it. But not anymore. 3 eggs, 2 ounces of salmon, half an avocado, a handful of spinach, 10 minutes, and a first bite that works with your biology instead of against it. That is all it takes to make the fast actually do what you were doing it for.